angles. Okay. So just a reminder about what we reviewed last time. We reviewed the triangle parts relationship theorem. Remember that the triangle parts relationship theorem told us that opposite the longest side length is going to be the largest angle, and opposite the shortest side length is going to be the smallest angle. So that was a triangle parts relationship theorem. So for this one, 18 would be our longest angle, our longest side length, sorry. And so opposite that would be the largest angle. So our largest angle would be A. Opposite our smallest side length, which is going to be AB, is our smallest angle. And so C would be our smallest angle. And then 16 would be in the middle. Okay? But today we're going to look at isosceles triangle. An isosceles triangle is a triangle with at least two congruent sides. Remember the keyword here is at least two congruent sides. And an isosceles triangle has two base angles and one vertex angle. The two base angles are going to be located at the base, and so that's why they're called base angles. And the vertex is going to be located at the top vertex, so this top part over here. Okay, so this is the different types of angles that an isosceles triangle has. What we can gather from this are a few things. Well, if we have an isosceles triangle, then we know at least two of the side lengths are going to be congruent. In this instance, AB and AC are congruent, and we can know this because of this symbol right here that tells me they are congruent. Well, another thing we actually know is that if an isosceles triangle has two side lengths that are congruent, which it obviously will because it is an isosceles triangle, its two base angles are also going to be congruent. So that means that angle B and angle C are congruent to each other as well. So those two side lengths are congruent as well as the base angles. Okay. We also have here what is known as the vertex angle in an isosceles triangle. The vertex angle in an isosceles triangle theorem states that the bisector of the vertex angle of an isosceles triangle is the perpendicular bisector of the base. So a vertex angle bisector basically cuts the vertex angle into two congruent halves. So a bisector cuts an angle into two congruent halves. So in this instance, the vertex angles T was cut into two congruent halves. What this is also telling us is that same line that cuts that vertex into two congruent halves also cuts the base into two congruent halves. And so because of that, we can determine that QR and RS are going to be congruent halves. Okay, that being said, say that I have a triangle, an isosceles triangle, specifically. And of course, I have my two base angles and I have my vertex angle. Well, so then I know that my vertex angle is equal to 80 degrees. And then I know that my base side is equal to 10 units. What this is saying is that if I see a bisector of that vertex angle, not only will it cut this angle into two congruent halves, so 40 and 40, it would also cut that base into two congruent halves, so this would be 5, and this would be 5 units. So that is what the vertex angle of an isosceles triangle theorem states. Okay. Now we're going to look shortly at isosceles and equilateral triangles. What we learned is that an equilateral triangle is basically an isosceles triangle because an isosceles triangle has to have at least two congruent sides, and an equilateral triangle tells us that all three sides are congruent, meaning that we satisfy the characteristic of needing to have at least two congruent sides. At least two means at most, or at minimum 2, but it can be more than 2. So what we're going to look at today is we're going to look at the corollary of the isosceles triangle theorem. What this theorem tells me is if a triangle is equilateral, then it is equiangular. You want me to show it up there, right?
No, you don't have to. They're actually going to do more like an interview type.
Okay.
No way. They'll just talk to you how you're using it, like the way you're using it, and now you can take it and kind of just say how you're using it.
Okay. I'll probably be available in like 20 minutes or...
Like 20, 30 minutes. Yeah. Okay, when you're done, can you head out to the library? And
yes.
I'll just have either Mr. Linan, maybe they can go to Mr. Linan's class. I'll let them know.
Okay.
You can just Tell them and they can go together.
Okay, sounds good.
Or I'll just tell them.
Okay.
They'll be okay, right?
Yeah. Yeah. Okay. Okay. So the corollary of the isosceles triangle theorem. This tells me if a triangle is equilateral, then it is equiangular. Well, that is what we learned about equilateral triangles, right? We learned equilateral triangles have 3 equal sides, and they also have 3 equal angles. If those sides are going to be equal to each other, then those angles are also going to be equal to each other. So that's basically what the corollary tells me. If all my sides are equal, then obviously all my angles are going to be equal. The converse of that will just tell me if all my angles are equal, well, then all my sides are going to be equal. So that is basically what the corollary of the isosceles triangle theorem is. Okay, and just a heads up, if all my angles are going to be equal, and I know that all of my interior angles of a triangle are equal to 180 degrees, then all I have to do in order to find out what my equal angle measures are is I take 180 divided by 3. Why? Well, because I know my sum of my interior angles are equal to 180, and I know that I have 3 interior angles. And so if I divide 180 by 3, I get 60. That tells me that each of my angles, which are equiangular, so they're equal, the same, they're all equal to 60. Okay? Again, equilateral means all sides are congruent.
Okay.
And equiangular tells me that all angles are congruent. Okay. And so that is the corollary. So let's apply all these different things we looked at. First one, let's apply the isosceles triangle theorem. It says, what are the measures of the base angle and the vertex angle of an isosceles triangle? Okay, well, what do we know? We know here we have an isosceles triangle. And we know that based on that, our base angles are congruent, right? We learned that from this one up here. So if our base angles are congruent, we can equal those two together to find x. Like this. So now we can find x. So we want to subtract negative 4x from both sides. Plus 15. Plus 15. 24 equals 4x. Divide by 4 on both sides. X is equal to 6. Now I know that x is equal to 6. I can plug that back in to find those missing angle measures. So that's equal to 33. And obviously this would also be equal to 33, but we can check it. Okay. Now, but it's also asking us to find the measure of that vertex angle. Well, we know that all the interior angles of a triangle are equal to 180. So we're going to see what the missing angle is. So minus 33, minus 33. So I'm finding what my missing angle measure is. And I will see that that is equal to 114. So my vertex angle is equal to 114. And both of my base angles are equal to 33. Okay. Remember that the first thing we do is we see that the two angles that we're given are base angles. We know our base angles are congruent to each other, so we can solve for x. Once we solve for x, we plug those in. And because we know that all the interior angles of our triangle have to equal to 180 degrees, we can subtract that from what we already have, and we see that we still have 114 degrees to distribute to our vertex angle. Okay. Now let's apply the vertex angle of an isosceles triangle here. Remember that we saw that the vertex angle, when it is bisected, it not only bisects the vertex angle, but it bisects my side length on the bottom, right? So it creates two congruent halves. And so because I know that D is being bisected, my vertex angle is being bisected, I know that these two halves are going to be congruent. So now it says line segment BD is the angle bisector of ABC. If the measure ABD is, and we're given our measure, what is the value of x? Well, the first way to answer this is to identify the that if this is 90 degrees, right, that's what that symbol tells me, and these two angles share a line, then this angle is also equal to 90 degrees. 90 plus 90 is 180. They form a straight line. And what it also tells me is that ABC, which is that angle B, is equal to 90, and it's giving me an equation to find x. Basically, what I can do is I can do 32x minus 6 equals 90.
Live your life. Live your life.
So plus 6.
It's like year 3.
So x is equal to 3. Okay, so the first thing we identify is we want to identify, do we have any information about what b is equal to? Yes, we do. B is equal to 90 because 180 minus 90 equals 90. So that missing angle will be equal to 90. Now that I know that the angle is equal to 90, but it's also equal to this equation given, I can use this to solve for x. And so x is equal to 3. Okay. I have like the rolling one. I don't have the pink one.
The teacher has white out a little brush.
You can.
So you ready to
Okay. So now we have the same thing. We're going to do the vertex angle and isosceles triangle theorem, but this question is a little bit different. This one tells me if AB, side AB is equal to 21, and BC is equal to 2y minus 3, what is the value of y? Well, what I know about a bisector is that it cuts my angle into two congruent halves, but it also cuts my side into two congruent halves. And so that means that this side and this side will be congruent to each other. So that allows me to solve for y, because 21 would be equal to 2y minus 3, because AB would obviously have to be congruent to CB. So I can solve for y plus 3, 24 plus 2y, divide by 2, divide by 2. Y is equal to 12. Okay, so using that information about that bisector, I'm able to identify that my angles get bisected into two congruent halves and my sides get bisected into two congruent halves, specifically my base side. And so that's how I can solve. Now this next one we're going to work with, this does with the corollary. This is the last example problem. Remember, the corollary told me if I have equal sides, then I have equal angles. If I have equal angles, then I have equal sides. Okay? So this says the measure of BAC. So BAC is going to be this one right here. Is equal to 5x minus 20. What is the value of x? Well, what I just discussed with you is that if I have 3 equal sides, I have 3 equal angles. So I'm going to take 130, the sum of my interior angles, divided by 3, and that's going to be equal to 60. That tells me that this angle is going to be 60, this angle is going to be 60, and this angle is going to be 60. What this is telling me is angle A is not only equal to 60, but it's also equal to this equation, so I can put those equal to each other. And so therefore, x is going to be equal to so AE equals 5x, divide by 5 on both sides. X is equal to 60. Okay, so this one just says if my sides are congruent, then all my angles are going to be congruent. If all 3 sides of my sides are going to be congruent, then my angles are going to be congruent. So I can solve for the measure of each of my angles. I also know that that angle is also equal to 5x minus 12. And so I can use that information, equal them together to solve for the measure of angle x, which is going to be 16. Any questions? So what did we review today? We looked at all these different theorems, okay? We looked at the isosceles triangle theorem, which basically tells me if I have at least 2 congruent side lengths, Then I have an isosceles triangle, which means my base angles are going to be congruent. Okay.
I was thinking that's the case.
The vertex angle of an isosceles triangle theorem tells me the bisector of the vertex of an isosceles triangle is perpendicular to the base. So basically, if I have an isosceles triangle and I have a vertex, that vertex is not only going to cut my vertex angle into two congruent halves, but it's also going to create two congruent side lengths on either side of that vertex. Okay. Next one, corollary of an isosceles triangle theorem. This one says, if all my sides are equal, they're equilateral, then all my angles are going to be equal. They are equiangular. Okay, any questions about these theorems? And we'll go over some more examples tomorrow. But if there's no other questions, you guys may log off. And I will see you guys tomorrow. Bye, guys. Bye.